probably help get you a working many years soundboard, which is actually annoying to find, although you can download the plans. Apparently it's not trivial to build, since the first shop we hired to build them screwed it up. Now we may do with only 2 ears. We've got all this weird stuff around our ear, right? Where these microphones don't have all this complex cupping around the ears. So there's a couple on the shoulders. But Windows 8, it gives a very nice heat map of where the sound is coming from. Right? I'm quite excited about playing with sensor fusion from sound and vision in that way. We also have plans to make touch work in a kind of tricky way, because this patented material called Frubber. So this is it's very soft material, and you can come up and touch it afterwards, as long as you don't rip it up or something. That's a patented material designed by David Hanson in the U.S. some time ago, and it uses a patented methodology to make little fluid bubbles appear inside the silicone. It's quite soft, so that a small movement by one of the 30-something motors in her head can make a variety of expressions, as you've seen. And another kind of incidental aspect of the Frubber is it's translucent to infrared light. So if you put an infrared sensor behind her face, she can sense when you're touching her. So it's like a fake sense of touch by light sensing. Now there's also a variety of technologies to get real touch to work, of course, by putting physical sensors on the outside of the skin. But getting fake touch by infrared is almost free with this infrastructure, although we haven't done it yet in this robot. And then that will let you sort of combine vision and touch. We can also combine vision and sound. And that's a deep point that I can't get into much in this talk, but I think that sensor fusion is cognitively important. And I mean, if you have just one sense, you sort of can't distinguish the world from that sense. But if you can sense the same world with many different senses, that's the beginning toward understanding subjectivity versus objectivity. It's the beginning of understanding that the thing is not the same as your sense of that thing. Because you can sense that thing by vision, you can sense it by touch, you can sense it by hearing. So you're getting the idea that what you perceive of the thing is one thing, and there's some abstract thing separate from what you perceive of that thing. And getting that idea from your embodied experience in practical life is an example of the kind of learning you can do in the real world better than in the game world. I mean, similarly, I remember when I was 5 years old and got glasses for the first time, and everything wasn't a blur all of a sudden. I realized, wow, the world doesn't exist. Right? Like, this stuff only exists as I perceive it, and it completely blew my mind. I haven't been a scientific materialist since that point. But I mean, again, that comes from having a world with so much richness that you can sense it badly and then sense it better. You won't get that in Minecraft, where you can just sense everything that's there quite directly. So all this mess of microphones and boards and so forth helps the system get a rich sensorium, which I think has ultimately a bunch of cognitive value. So there's an AIML chatbot. We've made some extensions to how a normal AIML chatbot works to make it work better, but our AIML plus architecture is what was driving these amusing conversations you were seeing while I was trying and failing to get PowerPoint to work, and then swapping laptops. And we do with English and Chinese. And there's a web user interface, which we may step you through a little later if I don't run out of time, which lets you trigger different animations and monitor the speech coming in out of the robot. Look at the motor configuration, and also lets you control various parts of OpenCog that control the robot. So just high-level diagram of this head framework, and this is in the OpenCog usage. I mean, OpenCog can be replaced with a chatbot instead, if you wish. But we have some basic vision and sound tools if you use OpenCog. The OpenCog goes out in a text-to-speech engine. There's also the option to use what's called a timeline editor, which is where you just script behaviors. If you want the robot to give a speech, you can just script that speech. Right now, these things feed through Blender, which is a game engine / art program that controls an animated character. That Blender animation then translates to a different component that translates the movements of the animated character to the actual motor commands of the robot, that goes to the robot. And actually, I'm a fan of removing Blender from this pipeline, but that's somewhat contentious within Hanson Robotics at the moment. So we may end up with a Blender version and a parallel version that doesn't use Blender. But it's nice to be able to visualize on the graphical avatar what the robot is doing. On the other hand, Blender has the annoying property of using half of the cores on your machine for no good reason, which kind of pisses me off. So, but this is an innovation in Hanson Robotics, which is sort of using these art programs like Blender, Maya, 3ds Max, using these art programs to animate and visualize a robot. Because normally when people program robots, it's done in a software sort of way where you write code that communicates with motors. But there's this whole infrastructure of graphic art programs, and they're making beautiful characters in movies and so forth. So using that art authoring infrastructure for robots it's an interesting workflow in innovation. So a lot of future work. I mean, we may replace Blender in the pipeline. We're going to put bodies on there instead of having just heads. We don't yet have a full-on robot simulation of the robot head. So one of the things we're doing this summer is carefully measuring the properties of Frogger more carefully than we have before to make a soft body model in Gazebo of the robot's face. And then right now, this is a research prototype. I mean, the motors break reasonably often. I mean, they wear out and they're too expensive. I mean, the motors in the neck cost a couple $100 each. So the hardware team is figuring out ways to make this thing for $500 to $1,000 ex factory cost at scale by working with motor companies to make better motors that are both cheaper and more reliable, working with gearbox companies to make better gearboxes, modifying the chemical formula underlying the Frogger face so it can be made in standard plastic extrusion equipment. So there's a whole bunch of stuff being done to make the robot lower cost. And along with that, we want to make the software all around on embedded devices. We've even started talking to some hardware guys about making an AI chip, especially for OpenCog, to make OpenCog run efficiently on hardware, much in the spirit of the many deep learning chips that you see coming out now. And overall, before I moved to Hong Kong, I didn't really know fuck all about hardware. I mean, I've done some robot tinkering, and it's been one of the interesting things about living there is being close to this Shenzhen, Dongguan, Guangzhou, hardware manufacturing ecosystem. You see there's a whole world there of making chips and robots and so forth, which we tend to forget. The U.S. leads the world in software development, and South China leads the world in low-cost scalable hardware development. And both of these things are important and are coming together. So, talk a bit now about OpenCog, and many of you have heard about OpenCog before. I'll go through this stuff relatively quickly, partly because I wasted most of the presentation trying to get PowerPoint to run. So, OpenCog is a platform which is oriented toward creating advanced AGI, and we've been trying to distinguish more cleanly between OpenCog as a platform and a specific design for AGI implemented on top of OpenCog, which I had been calling OpenCog Prime, and now with my usual abundant creativity have reorganized the name to Prime AGI instead. So OpenCog being a platform, Prime AGI being the specific AI design built on top of there, and there's not as clear a distinction there as we would like it in the code, but I think it's a valuable distinction to work with. As a platform, OpenCog is centered on the atom space, which is a weighted labeled hypergraph kept in RAM. It can be persisted to Postgres, which is pretty mature, or to Neo4j, which is less mature. Then there's a bunch of tools that act on that weighted labeled hypergraph data structure. So the hypergraph, the atom space, is neural symbolic in the sense that you have some links that are weighted more like links in an attractor neural network, and you can do activation, spreading like stuff along, and you have some links that are strictly typed, like in a logic system, and you can do probabilistic logic inference on that using our probabilistic logic networks framework. And so we do the logic stuff and the neural net stuff in the same network, which is not the only way to do neural symbolic stuff, but is one way to do it. So it's very tightly integrated as a neural symbolic system. And then there's multiple processes that run on top of that atom space, getting nodes and links out, doing stuff with them, putting new nodes and links in, basically. So that, I mean, at the most nitty-gritty atomic level, the processes are all modifying hypergraph nodes and links, deleting them or adding new ones. But that's very broad, right? Like heavy and running builds a new link between two nodes or two links. Logical reasoning takes link structures corresponding to premises, derives a conclusion, and puts that conclusion in the atom space as a link structure. So it's all about atom space manipulation. So you can't read the labels there, but there's an atom space visualizer that shows nodes and links. This is from this is more semantic network stuff. Like the middle node is Bob. Bob tells the truth about something rather that I can't read. But you can zoom in and zoom out and expand different nodes and filter out which nodes and link types you want to look at and so forth. So that's a JavaScript-based graph visualizer. So, yeah, there's something called the COG server, which runs various mind agents, which are processes that interact with the atom space. And the mind agents can be run in parallel. For example, logical inference, as I mentioned, and what we call ECAN, which is the economic attention allocation. And you can interact with the atom space via a REST API, via ROST messages, or via a scheme API, which is heavily used. So Prime AGI is a conceptual architecture and sort of a theory of mind and a theory of AGI that works on top of this OpenCog platform. So the platform I just described is relatively generic in nature. I mean, a lot of things can be implemented on a weighted labeled hypergraph, and running processes that interact with that weighted labeled hypergraph could be done in many, many different ways, right? But OpenCog doesn't in itself tell you how to build an AGI on top of this hypergraph. So to do that, you need a lot more assumptions. You need to know what knowledge representation scheme you're using inside that hypergraph, and you need to know what cognitive processes are acting on that hypergraph. And this has been one of my learning processes over the years. I mean, in my first attempt to build an AGI of this nature in the late 1990s and then early aughts, I sort of thought, just take a bunch of intelligent processes and like stack them on top of a knowledge representation. Get one that does language, one that does logical reasoning, one that does visual perception, one that does episodic memory. Get them all to work together on this common knowledge representation. And then there you are. They'll all interact and do their thing. And what I realized eventually through trying is that makes a big mess. And that was where Pei Wang and I were involved in between 98 and 2001. And Mike, who's up here, was involved with that too. So they can, Pei is very aware of that big mess. And actually some of his NAR stuff was part of that happy mess at the time. So what I realized afterwards is to get these different cognitive processes to work together effectively on the same knowledge representation, you need to put a lot of thought in how the different cognitive processes work together. And of course, Pei knew that all along back then, but he had a different way of thinking about it. Pei really takes a certain logic as central and wants to build different sort of cognitive processes all using that same logic as the central thing. And in my approach, logic isn't necessarily the center, but we need to have logical inference for dealing with declarative knowledge and different methods, such as evolutionary methods for dealing with procedural knowledge. We need to have certain sorts of pattern recognition for dealing with episodic knowledge. We need to use different stuff, more like deep learning for perceptual and sensory motor knowledge. We need to use stuff more like attractional neural networks for attentional knowledge, for spreading attention around. But the different learning and reasoning algorithms you need to use for different kinds of knowledge all need to be made specifically to work together. Now, evolution got that for free, in a sense, and because it took so long to come about and grew from dumb integrated systems to smart integrated systems. So as those dumb integrated systems through evolutionary time got smarter and smarter and became smart integrated systems, all the parts work together very well. I mean, the different parts of the human mind evolved to work together. So I mean, we got better at using tools. At the same time, we got better at using language. At the same time, we got better at doing social inference. And these capabilities evolved to work together. Now, when you're engineering a system, you don't have to do it that way, right? You can take totally separate systems that work in completely different ways and glom them together. The problem is it just doesn't work that well. So you have to do by thinking what evolution did, just by the constraint of building working systems that got incrementally better and better. And you have to make the different parts of your system speak the same language and help each other out and adapt well. One way of thinking about that is in terms of combinatorial explosions. I mean, pretty much every AI algorithm fails at some point due to hitting a combinatorial explosion of some sort when either the data gets too much or too diverse or something. And the normal way of dealing with that is putting in domain-specific heuristics in one way or another. And when you're dealing with general intelligence, that specifically doesn't work. AGI, general intelligence, can't be domain-specific. It has to be able to generalize from one domain to wildly different domains. But then you can't prove combinatorial explosions with domain-specific heuristics. So what can you do? I mean, so one idea is, if you have a number of different learning algorithms, perhaps dealing with different kinds of knowledge, if each of these different learning algorithms can help the other ones to prune their combinatorial explosions, then you can have what I've called a cognitive synergy, which is a phrase some people love and some people hate. People who've dealt with management consultants have heard too much about cross-pollinating intergalactic business synergies or something. Got the sake of the word. But I learned that from reading Buckminster Fuller stuff when I was in grade school. So I love Bucky Fuller, so I love the word synergy. But that's what it is, really. I mean, it is emergence. You need something where each component gains more intelligence in combination with the other ones by some synergy, some emergence with the other ones. For example, your logic engine, when its combinatorial explosions run amok and it can't decide which inferences to choose, it's got to be able to rely on something learned via, say, Hebbian learning to help it prioritize. So, okay, which inference step do I take? Well, I'll take the inference step that my Hebbian learning says has more activation right now. On the other hand, your Hebbian learning, the Hebbian learning needs some good raw material from which to build its Hebbian link. So Hebbian learning will build a link between two things that are important at the same time. Well, why were two things important at the same time? Well, one reason is because you saw them both at the same time, right? But another reason could be that the two things were being logically reasoned about in the same reasoning chain, right? And then if two things are important at the same time because they're being logically reasoned about in the same reasoning chain, then Hebbian learning builds a link between them. That Hebbian learning then helps prune logical inferences, combinatorial explosion later. So then you have a sort of synergy where Hebbian learning and logical reasoning are each helping each other to be more smart and less stupid and better deal with the combinatorial blow-up of possibilities. So that idea is really at the core of prime Prime AGI, and Prime AGI as an AGI design is certainly not complete at this moment. I mean, it's maybe 35–40% there, I would say. I mean, hard to put a number on because you don't know how hard are the obstacles that you face, but you only know how hard are the ones that you've already overcome. So, I mean, what we can do now is use specific components that we have implemented in OpenCog in the spirit of the Prime AGI design. We can use those components in specific applications, and as researchers, we can try to build out the system more and more until we get to the whole thing. I mean, there's one weakness of this theory is if the underlying theory is right, you're only going to get really advanced general intelligence once you have all these different components implemented and working together to help each other. And when you have just a fragment of them there, you may not get something that's all that smart, right? And that is it's a weakness of a sort of synergy-based approach. And I'm not entirely sure that's avoidable. It might or might not be. I mean, a human body has a kind of similar property. If you were building a human body, until you get a lot of the key parts in there, it's going to be dead, right? I mean, you need the heart, you need the lungs, you need the autonomic nervous system, you need these blood vessels, you need some skin to contain it, you probably want some bones to hold it up, and you get these pieces together, and they work pretty well as a system. Once you put only like 2/3 of those pieces together, you just have a kind of hopeless lump, right? So this sort of synergy may or may not be a necessary characteristic of an AGI, but it certainly is reminiscent of the sort of interdependence you have between parts of living systems. So yeah, there's the atom space. Just to briefly run through the various components. There's probabilistic logic networks, which has been talked about at many previous AGI conferences and is described in a couple books. So this is a logical inference approach which combines probability and logic quite thoroughly. Economic attention allocation, and which spreads attention around through the atom space. There's something called Moses, which learns new programs and procedures, which are represented as little chunks of atom space. There's a pattern mining algorithm, which is this sort of greedy algorithm, much like a priori or FP search, but it works on weighted labeled hypergraphs rather than tabular data. There's algorithms for concept blending, building new ideas by putting old ideas together. It says who knows about a gerbil and a human, we can fuse them together to make the idea about a gerbil man, right? It can take concepts that exist diffusely as sort of cell assemblies of nodes and group them into single concepts. For motivation, we use something that is modeled loosely on Joscha Bach's microsize system, which was again modeled on Dietrich Dorner's size system before that. And then we connect with perception and action systems. And right now, say for controlling this robot, we're using totally separate computer vision systems. But in our research group, actually in our research lab in Ethiopia, in Addis Ababa, we have a couple people working on putting deep learning inside OpenCog. So the actual hierarchical deep learning network is inside the atom space, which should let you interconnect cognition with perception better, although that remains a hypothesis. We have an end-to-end English dialogue system, so you can speak to it, it will speak back to you. It maps what you say into nodes and links, and then turns those nodes and links back into English after doing some reasoning on them. So there's some rule-based pieces there for syntax understanding, but the rules are used to turn English into semantic nodes and links, where it can then be reasoned on and turned into English again. And I mean our grand plan here, if you think about it in terms of the history of the space program, our grand plan is, I mean, first build what we can think of as the V2 rocket of AGI, a system that really shows the core principles work, shows that cognitive synergy will yield general intelligence. Then next step, something that shows incontrovertible evidence that it has achieved AGI, and from then on you're just getting smarter and smarter. So our first goal is to make a robot head like this show real basic sentience, so that it understands who it is, where it is, what it's seeing, and what it's doing. Even if it's in some ways dumb, it's at least not as dumb as a brick, right? I mean, it won't be intelligent in exactly the same ways as a young human child, but intelligent in at least some meaningful ways. So it knows who it's looking at, knows that it's looking at a person sitting on a chair, knows that it's a robot sitting there looking around through some cameras, and can hold some basic conversations showing just self and other awareness. And that, we're not there yet. I mean, by our best estimates, it's maybe 2 to 4 years off of research if we're reasonably well funded in our work. I mean, I wish it were 6 months off, and it might be if things go insanely well, but that's not that likely. But it's not decades off either, unless the whole paradigm is screwed somehow. And then beyond that level, the next step is to proceed more and more toward human childlike learning, and think about getting a robot that could go to 3rd grade, 1st grade, and so forth, and learn what's being taught. Like, once it's got basic situated understanding, then it can learn from a teacher, and it knows it's learning from a teacher. It wants to please the teacher because it has some emotional connection to that person, and knows that's the person there who's teaching it. And then the skills that it learns are learned in a grounded, embodied, situated context, and are quite different than those skills in a narrow AI system that acquired similar-looking skills via hard coding or via supervised learning from an annotated corpus or something. And then once you're there, I wouldn't say things get easy, but you're playing a quite different game, because you would have a huge amount of resources and brain power and hardware and everything going into taking the next step. So right now, most our thinking is going into how to get the robot to have basic sentience using the OpenCog platform and Prime AGI design. I think we understand how to do it, but there's a lot of work there still. So don't have too much time left, actually. So I'm going to briefly talk about one particular aspect, and then we'll show a little bit more of the robot in maybe 5 or 10 minutes or so.
This was not supposed to end at 10:30.
Is it 10:30?
It says on the schedule.
All right, then we have a little more time.
Cool. It says on the schedule it ends at 10:30. It's after 10:30.
Ends at 10:30.
Unless it's after.
No, it's already after 10:30. Well, these are supposed to be 2 hours now. All right. Well, the break. All right. Well, all right. If it's supposed to end at 10:30, then this will be very, very brief. So, I'll show a couple videos.
Yes.
This was yesterday. I was playing with Sophia.
Turn left. Okay.
I'm in. And we may show this in the moment.
Turn right.
So
Okay.
yeah, this was.
Turn up.
She has
Okay.
at
Turn
least
down.
understands the connection between words and
Turn down. Okay.
between words and movements.
Look right. Okay. Be happy. Okay.
She's happy. Do you believe her?
Be sad.
And I mean, we can.
Mm-hmm. Who is Albert Einstein?
Albert Einstein was a German-born theoretical physicist. He developed the general theory of relativity, one of the 2 pillars of modern physics.
So, the difference between that and the AI mouth chatbot is, so in that case, when I asked her what is Albert Einstein, which we may show you that in a moment. So what she did there is she went online to get that information. But when she goes online to get the information she gets from online is parsed, the English sentence is parsed, it's turned into a semantic graph, then that knowledge is stuck in her atom space, right? So she is grabbing the information from the internet, and that case using DuckDuckGo's API actually. But once she gets that into rabbit space, then if you ask her that same question again, then she answers it from her own memory. And some of that stuff she actually has some reasonable knowledge about. So she's a physicist, so she has knowledge from other data that she read before, that a physicist is someone who does physics, for example, and knows that a physicist is a person, right? So as she said from the internet, Albert Einstein was a physicist. Once she's downloaded that information in her rabbit space, then she knows, okay, Albert Einstein is a human, right? And that's a fundamental difference from something like an AIML chatbot, because the AIML chatbot is representing things as text, right? And OpenCog is representing things as these semantic graphs. And so what we're engaged with doing is taking stuff that comes from vision. So say it knows who I am. It doesn't know who Mike is, but it could learn who Mike is by looking at it enough times. So then it knows that me and Mike are sitting next to each other. And if me and Mike both said the word physics over and over again, right, it would learn that people standing next to each other tend to talk about physics a lot. And eventually, after a while, it might learn that people next to each other tend to talk about the same things a lot, right? And that's induction from experience coming from a combination of sound source localization, vision, face recognition, and then the abstraction of pattern mining and reasoning that's happening through OpenCog's mind agents. And this kind of trivial, basic learning, combining seeing, hearing, acting, because it has to look at us, and reasoning on language. This is what I think is valuable about getting AGI to work in a robotic environment and interacting with the actual world. Now, we're now at a quite early stage in this project. Like in the last 2 weeks, we have gotten OpenCog to control the robot fully for the first time, and it's worked better some days than others. So yesterday, to be frank, it was working quite badly. This morning a little better. Tuesday significantly better. Hopefully tomorrow even better. But it's the first couple weeks, and I think as this fall unfolds, we're going to see OpenCog display more and more intelligence through the robotic embodiment. At the same time, we would love to see other people use this software framework to test out their own AGI systems. And one of the videos that I didn't get to show because of the dysfunction of my MacBook was of our Blender framework, which is sort of animated version of the robot, which runs in software. So you can use the same software framework to control an animated robot head on your laptop as you used to control this physical robot, which is mostly how I do development work. But then now and then you can try things on the actual robot. So is she actually doing anything?
All that information from your slides you can find online.
And more. Even she can find it online.
Hi there, what is your name?
My name is the Great Satan.
Hi there.
Smile. Look sad. You fell. Look sad. Look sad. Google Voice doesn't like my diction. Look angry. Look like a frog in heat. Turn right.
Okay.
Turn left.
you have to hold the microphone consistently.
Turn left.
Okay.
Is it correct? Because she turns right when you flip.
She's displaying empathy. Who is Jim Rutt? No, you don't know? Is that dude over there? Speech to text is not working? Probably the internet in this room, actually. Who is Jim Rutt? And Google Voice speech to text is failing, probably because it's trying to use Wi-Fi. Huh?
Jim Rutt is an American businessman and entrepreneur, the former CEO of Network Solutions, and the former chairman of the Santa Fe
The
Institute.
internet knows everything. That is correct. Go baby.
Thanks for explaining correct.
Tell me something about the philosophy of consciousness. She doesn't want to. How about the
You
meta?
must be very fond of it. I'm not sure if I can quantify the answer. I'll ask around and get back to you.
Ooh. What do you prefer, metaphysics, epistemology, scatology, or eschatology?
Sour milk.
There is in there a module for amusing philosophical disquisition that I seem unable to access it, probably due to just speech to text Wi-Fi problem.
Is there only one?
There are many.
Are there?
Tell me more about the relation between God and fundamental physics in the universe. Why do you exist?
Live anywhere. Where would you live? They say a lot of silly things.
So, to briefly wrap up when you grab some coffee before it all goes away, I mean, last year at the AGI conference, we showed off this robot, and in essence, it had nothing to do with OpenCog or my AGI work except in the realm of intention. Right? So, this year, we actually feed perceptions and language coming through the robot, through all these sensor systems into the OpenCog space, and the OpenCog space triggers ROS messages that make the robot do stuff, and that involves responding to simple commands, asking some questions, and some basic self-awareness. And we've just gotten this to work in the last couple weeks, quite hot off the presses. So if the trajectory continues, next year we'll come back with this or an even better robot, and we'll actually see some interesting OpenCog intelligence displayed through the robot. And it's been a heroic effort just to get everything integrated, and I hope I've conveyed some of the infrastructure that goes into that, just from the motors to the face to ROS messaging to speech to text and vision for face tracking. There's a lot of pieces, and I think that's just how it is. The human body has a lot of pieces. Some are dumber, some are smarter, and they've all gotten to work together. And incremental progress feels slow when you're doing it, but in the historical sense, just a few years to go from a completely dumb robot to one that knows what it's doing will seem insanely rapid. So now, I hope we can all be insanely rapid